Well, I've got a Sharp micro component system, XL-DK255, and I've got the lights off in here right now. And as you can see, the timer light is blinking a code, one long blink, another long blink, and then 4 short blinks. Well, let's see if I can find any kind of service data on this unit. Okay, well, according to the service manual, if I see one long blink, 4 quick blinks, and then one long blink, then a pause, which is exactly what I'm seeing, it's telling me that I have an abnormal detection and B+ protection display. In case speaker abnormal detection or +B protection has occurred, unit will automatically enter to standby mode and timer indicator will flashing as below. Example, in case of speaker abnormal. So number 1, one long blink, off. Number 2 is 4 fast blinks, and then off, and then one long blink, and then a pause. I'm having trouble deciphering this because it looks exactly the same for number 1, B+ protection, or number 2, speaker abnormal. Anyhow, that's what I'm coming up with in the service manual, so let's go ahead and see what we can come up with. Okay, well, I've got the unit open up right here, and as you can see, right down in this corner right there is a standby transformer and a relay right there. Might be kind of hard to see. And then this is the main power transformer. So I believe this is an Energy Star compliant unit. Yes, it is. It has the Energy Star logo, which means it has to draw 1 watt or less in standby, which is why they have this little transformer right down here that draws very low current. And its job is to run the microprocessor and pull in this power relay, which energizes this large iron core transformer, which is definitely going to draw more than 1 watt just sitting and idle. As you can see, it has a little cooling fan back here. There is an STK chip mounted on the back of this heatsink that I can't see right now, and it looks like a little regulator or a switching transistor over here on the side. Anyhow, there's the big bridge rectifier. I think the main filter caps are probably over here on the main amplifier board. But let me tip this up and you can get a better view of the power relay down in there and the standby transformer. And there's really not much to see on the other side other than you can see a little bit of heatsink compound oozing out under the STK chip right there. So I'm thinking at this point it has a standby power supply issue, and I'll show you why I think that is the case. So the power is applied to the unit right now, and I have my voltmeter on the coil of the main power relay. And if I go ahead and try to hit the power button on this, I see about 1 volt. So let's put it in min-max and see what our maximum voltage actually is. 1.3 volts, and then it drops off. If you look at the bar graph right here, you'll see it comes up and then it drops off. And I believe that is what is fooling the microprocessor into thinking that it has a power amplifier protection issue because it's not getting the B+ voltage that it wants to see. So let's take a look at the standby power supply and see what it consists of and what controls this relay and why it would only be getting 1.3 volts to the coil when it should have probably 5, 9, or 12 volts depending on the relay voltage. Okay, so here's the schematic of the standby power supply. There's the standby transformer. It gets 120 volts on this side and it outputs, I'm guessing probably about 7 volts AC. Goes into a full wave bridge rectifier and a single 470 microfarad filter cap. And from that it goes into a KIA 7805. That's a 5 volt linear regulator. And they added a diode between pin 2 and ground, so that effectively makes the output 5.6 volts. They take that 5.6 volt output through a 220 ohm resistor with a 1000 microfarad cap to ground, and they feed that in to the source side of the relay. Now the control side of the relay comes down here, and it's switched on by this transistor right here. So when it calls for power on, the base goes high, which effectively shorts collector to emitter right here and turns this transistor on. So let's go ahead and measure the voltage on the input to the 5 volt regulator the output of the 5-volt regulator, and then we'll measure the voltage on the voltage side of the relay and the control side of the relay also. Okay, hopefully you can see everything. This is the voltage side of the relay right here, and we see 5.6 volts, and when I press the power button, it pulls down to 1 volt. This is the control side of the relay, which should pull down to 0 volts, and it pulls down to 0.06 volts. Totally happy with that. This is the regulator right here. This is the input pin, so I've got 12 volts. When I hit the button, it pulls down to 9.9, 9.8 volts. This is the reference pin. It should be about 0.6 volts, and it is. And this is the output side of the regulator, and it doesn't flinch whatsoever. So I'm thinking next, I want to see if the relay is actually working. I hear a slight click when I hit the power button. So I'm going to go ahead and put my test leads in the AC volt range, and we'll go across the output side of the relay. So we're in AC. So we should see 120 volts there. And we do. Got the voltage up a little bit high. And I'll put this in manual, so when I press the power button, this should go to 0. And it stays at 123 volts, so the relay is not actually engaging. I do hear a click though. I wonder if the relay is just stuck. Now the other issue that could be happening is this 1000 microfarad capacitor right here, which is what is actually like a stiffening capacitor. It's only meant to help pull in the contacts on the relay. Once it's pulled in, it doesn't need that much voltage to continue to hold the contacts. So I want to go ahead and check the ESR on that capacitor. Now on a 1000 microfarad cap, I'd like to see probably maybe a 1/4 ohm or less. So let's go ahead and check that ESR and see what it looks like. So I know that the capacitor lives right here. So let's go ahead and measure from the negative lead to chassis ground, and we should get close to 0. And I see 0.04 ohms, and the actual ESR of that capacitor is 3.7 ohms. Well, once again in my book, that's a little bit high. Let me see if I've got a 1000 at 6.3 or higher voltage to replace that with, and we'll see if we get better results. And I do have a replacement Nichicon 1000 at 6.3. And it is a 105 degrees Celsius cap, so it is a good quality capacitor. Let's go ahead and check it. And I see 0.23 ohms on that one. Verify lead integrity is 0.0. Yes, 0.23 ohms, much better. So what they're using that capacitor for, like I said, is to actually just pull in the coil. So let's go ahead and replace that capacitor and see what happens. Okay, there is the original Jamicon capacitor. And just like I thought, 85 degrees. So we'll go ahead and pop the new Nichicon in there and see what happens. All right, new capacitor is placed on the board. Let's just go ahead and solder it up. Okay, let's reorient the meter and try to power this thing on and see what happens. Okay, here we go. Main power on. And we'll hit the power button. And the relay did pull in, and it's holding at 3.97 volts. And I even heard the speaker relay pull in. And I do actually have a display. So that is it. The capacitor that pulls in the main power relay was definitely bad. So I don't have the CD player in it right now. I'll go ahead and reconnect the CD player and see if it operates normally. Okay, here we go. Power on. Let's see what happens. And it's obviously trying to read a disc that is not in there. Oh, it's going to go check them all. Okay, well, we'll wait a moment. Oh, there is a disc in that one. Well, let's go ahead and take that disc out. And we'll go ahead and pop in a copyright-free audio disc. And we'll go ahead and ask it to play. And it's playing just fine. Now I don't have the remote with this, so I can't actually skip tracks. There's nothing you can do. You have play, stop, CD tuner, and video input in the disc 1, 2, 3, 4, 5, and open close. So I'm kind of stuck just playing the disc that's in it right now. But it's working perfectly. Let's make sure the other discs do work. So we'll go ahead and go to disc 4. Actually, stop it. Disc 4. See if there's a disc in that. And there's no disc. Stop it. Go to disc 5. And no disc in that, so we'll go ahead and open disc 5. Pop another copyright-free disc in it. And we'll hit play. Now this one has a long intro. And it's working perfect. Well, there it is. Turns out it was just that Jamicon 1000 microfarad 6.3 volt cap that was the entire problem. Well, I certainly hope you enjoyed the quick little repair and possible tutorial on the power supply repair on the Sharp, I don't even remember the model number, XL-DK255. Go ahead and leave me a question, a comment, a concern down below. Good or bad, I try to respond to the comments when I have time. While you're down there, if you could, please hit that subscribe button. It really does help my channel grow. And liking this video tells the YouTube algorithm that you like this video, and it does help my channel grow as well. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, norcal715videos@gmail.com. That is the best way to contact me. Please be patient. I do have a full-time job, and I do these repairs in my spare time. If you try to contact me on Facebook, Instagram, or Twitter, please be aware. It might be weeks or sometimes even months before I respond to those. I rarely check those. Please, if you want to contact me, use the Gmail only. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really do appreciate it. If you're so inclined to, have an awesome day. Thank you so much for watching once again. Bye-bye. So just a bit of bonus footage. If you're going to do one of these units, please be aware there are 3 different types of screws in this unit. There are screws that are meant to go into sheet metal right here with the fine, and I say fine in quotes, thread. There are screws that are meant to go into plastic with the coarse thread, and that's a short screw. And then there are screws that are meant to go into plastic with the long coarse thread. So if you're going through 1 piece of plastic, it uses the short screw. 2 pieces of plastic use the long screw, and into the sheet metal chassis, it uses the short, fine thread screw. So there are 2 short plastic thread screws, and they go just in the CD mechanism to the front panel. There are 8 short for sheet metal screws, and they hold the bottom sides on. There's 4 on each side, and then there are 6 long plastic screws that hold the top on, 3 on each side. Everyone have a great day. Bye-bye. And a little extra bonus footage if anyone needs a schematic for the STK43207 power amplifier IC. Just in case you're actually having a problem with that IC, here is the schematic for that chip. Here's the speaker relay right here, and that's where it exits the board basically. So what you're looking for, let me get a pointer, is your B+, your B-, inputs right here, speaker outputs right there, and then these are all bootstrap. There's an emitter resistor right there, a 0.22, another 0.22. So obviously this is a push-pull configuration. They didn't draw the second line there or the second line there, but it looks like outputs are on pin 6, 7, and then 10 and 11. And then filtering, bootstrapping on 12, 13, 4, and 5. And then positive input, negative input, 1 and 2. And once again, positive output, 15, negative input on 14. So hopefully this will help you if you're having a problem with this unit and you have a suspected STK failure. Everyone have a great day. Once again, thank you so much for watching. Bye-bye.